All right, so you're welcome back to the second video. This is 5.1. So here we'll be talking about angles in standard position. So what is an angle in standard position? We start. An angle in standard position is an angle that is drawn in the positive drawn in the XY plane with its vertex at the origin, and the initial side, the positive x-axis. So if the initial side is on the positive x-axis and the vertex is origin, then we can say that the angle is in what? Is in standard position. So if you look at this case now, this is an angle in standard position. Why? Excuse me. Because this is the initial side, as you can see, this is the positive. The initial side is on the positive x-axis. And the vertex is what? The vertex is at origin. Vertex is where the initial side and the terminal side. The terminal side is the blue line. Where they meet, you can see they meet at origin. And its initial side is starting from where? From the positive x-axis. So this is your theta. So we can say this theta is in standard position. Also in B also, you see the initial side here is the positive x-axis. So we go from here until we get to the blue line, which is the terminal. So this is also in standard position. And you can see also the vertex here is 0, 0, origin, because both the initial side, so you have something like this. This is the initial side and this is the terminal side. They all meet at where? The vertex, right? So this is also in standard position, as well as this also. But here you can see this C, we started from where? The positive x-axis, but we went round, then we touched the blue line. So you can see it's like a complete more than one circle, right? But it's still standard position because you started from where? The positive x-axis, and the vertex is at origin. Now, for this one, you also have the same, starting from positive x-axis, but now we go around about twice, 1, 2, to reach the terminal. So all these are examples of angles in standard position. So let me quickly give us an angle which is not in standard position. For example, if I have this, and let's say I have this one, I call it alpha. So alpha, you see, in this case, is not in standard position. Why? Though it starts from where? It starts from the positive x-axis, because this is the initial side, and this is the terminal. But the fact that the vertex is not at the origin, so this is not standard in standard position. So let me give you another example. Is angles that are not in standard position. I have this one here, and let's say I call here to be theta. So this theta is not in standard position. Why? Because the initial side is on the negative x-axis, right? So O, if you draw another one here, let's say we make this one. Let me give another example here. And now we do this and we put here to be theta. This theta is also not in standard position because the initial side is not a positive x-axis. Now, why is standard position important? It's because we want to find what we call coterminal. So now what coterminal simply means, coterminal means they share the same terminal, means the same terminal. So if you look at A and C, A, this is the terminal. So this is A, it's up here. And if you look at C, C is also the same because it shares the same terminal, because you can go around and then you come back to the same line. So we can say that angle A and angle C, they are coterminal, even though they are not the same, right? So if I call this angle, let's say the whole of this angle, let's say alpha. So you can see, but alpha is bigger than what? Than theta. So if you want to get alpha, you need to add about, let's say 360. So you see about 360 plus theta will give you what? Alpha, because you have to go round once. Yes, but they still share the same coterminal because this blue line is almost in the same, in the same position, right? So we say that what? These two angles, theta and alpha, they are coterminal. In other words, they share the same terminal. And that is also applicable to B and C. If you look at B and D, they also share the same terminal. But in this case, you will go around how many times? We go around 2 times. So simply to generalize, if you have an angle in standard position, right, to find the coterminal, we simply use this one, because we could go what? We have plus or minus. Why do we have plus or minus? Plus or minus simply means we can go clockwise or anti-clockwise, because here we can also decide to have a coterminal. Let's say I can have something like this. Let's say this is our terminal, so we can decide to go left. We go clockwise, and then we come back here. So you see this now, this theta will be negative. So in general, we use this formula to find coterminal. So let me modify this formula a bit. Let me just write it. You can use this coterminal. If you want to find coterminal, you can use your theta, whatever theta you are given, plus minus k as what? 360. So, or you can use plus minus k times 2 pi, depending if the angle is in degree or radian. But here, what does k represent? K is a natural number, meaning that k starts from where? K is the number of rotation. So it starts from 1, 2, 3 continuously. So k has to be natural number. So this is the amount of rotation. How many times are you able to rotate before you come back to the same terminal? So like in this case now, the k is what? K is 1, because you go around almost 360 back to the terminal. Here you have to go twice, starting from the positive x-axis. You go 1, we go again before you get back to this terminal. So we say B and D are coterminal. They share the same terminal. All right. So example 4, it said find the angles that are what? Coterminal with what? Theta equals to 30 degrees. So simply, coterminal is what? Theta plus minus k 360 degrees. So what is our theta in this case? 30 degrees. So you have 30 degrees plus minus k 360 degrees. So you see there are infinitely many of them. You cannot exhaust them because k here is a natural number. So that is why the question says find the angles. So you have a lot. For example, if you take k to be 1, we will have what? We will have 30 degrees plus minus what? 360. So from here only, you will get how many? You will get 2 answers. You will get 30 plus 360, you will get 390. Or you get 30 minus 360, which is minus 330. Right? So you can see, you take also k equals to 2. If you take k to be 2, will you have 30 plus minus what? 720, right? And here, this will give you what? You have 30 plus 720 will give you 750, or you will have minus 690. So the k keep changing. So the more you go rotation, the more coterminals you have. So in that case, you just need to leave your answer in a general form. So your final answer will just be in general form like this. So you don't have to list them. You just have to leave them in general form this way. Okay, the same way, but now for B, find the angles that are coterminal. Here, your theta is in what? Is in radian, so it means you have to change the formula. So this will be plus coterminal is theta plus minus k2 pi, where k is a natural number, right? So, but what is theta here? Is pi over 3 plus minus k2 pi. So just leave it like this because this is just general. You're finding the angles that are coterminal. So there are many of them. But for this example 5, here you have some restriction. You are looking for what? Determine the measure of the positive angles. So you need your angles to be positive, and you want them to be less than what? Less than 360. But they have to be coterminal to all of this, right? So let's start with A. So it means we are looking for the coterminal. So 400 plus minus K 360, right? So, but we need angles that are positive, and not just positive, but less than 360. So, but the original angle given here is already 400. So it means it is best to get something less than 360. You have to use minus. We cannot use plus, right? Because if you use plus, it will be bigger than what? 360. Then here you need to choose K. For example, if you start with K equals to 1, what do you get? We'll have 400 minus what? 360. And this is equals to what? 40 degree. And you can see 40 degrees, okay, because 40 degree is positive and it is less than 360. So it means that 40 degree is a positive angle, right? Which is less than 360 and also coterminal to what? To 400. So what that means is that, let's try to illustrate this, what it means. It simply means that what? If you have, and as you can see, this is 40 degree. 40 degrees somewhere here, right? 40 degrees somewhere here. If you are looking for 400, where will 400 be? 400 simply means you go, because by the time you go and come back once, this is 360. So, but you need 400. So this will be 400. The red one is 400. Yes. Because by the time you move from the positive x-axis, you reach here, you are already 360. But to get 400, you have to go 40 more. So you can see that 40 and what? 400, they are what? They are coterminal. All right. Now, why is this the only answer? Because if you take, let's say, if we take k to be 2, what are we going to get? If we take k to be 2 instead of k to be 1, we will have from here, we're going to have 400 minus what? 720, which will become a negative number. So we don't need that. So the best one is k equals to 1. Now, for B, is the same thing. This is what is going, in this case, is going to be minus 120 degree plus minus k 360, right? But since the angle is already negative, we want to make it positive, right? So in that case, we should go with positive, not negative. So if we try k to be 1, if you take k to be 1, what do we get? We'll get minus 120 degree plus what? Plus 360. And I think this will do it, right? So this will give us, I think 240, right? And this is positive, right? Yeah, this is positive. and it is what? It is less than 360. Yes, so this is good. All right. For C, C is 17 pi by 4. So for this now, we have to find the coterminal, which is 17 pi by 4. We will check first, plus, minus, but here now we have to use K2 pi. But if we look carefully, we'll see that what? This is 17 over 4. 17 over 4 is bigger than 2, right? So it means that 17 pi over 4 is what? 17 pi over 4 is definitely bigger than 2 pi, right? Now, since it's bigger than 2 pi, we are not going to use plus, so we should go for the minus. So we have minus K2 pi. Then here now you have to check which K can we use. If we use K to be 1, is it going to be nice? For example, try K to be 1, it will become 17 pi over 4 minus 2 pi, right? So if you subtract 2 pi, what do we get? 2 pi is the same thing as 4 pi over what? There's 2 pi is going to be 8 pi, right? Over 4. Now, if you do that, this will give us 17 pi over 8 pi over 4, right? Yes. So what will this be? I think this will be 9, right? 9 pi over 4. But if you look at 9 pi over 4, it's still bigger because 9 divided by 4 is about 2 point something. So it means this is still bigger than what? This is still bigger than 2 pi. So this is still bigger than 2 pi. So it means we have to take K to be what? We have to take K to be 2. So remember here, we choose K to be 1. Okay. So let's take K to be 2. If K is 2, we will have 17 pi over 4 minus what? Minus 4 pi, right? And this is going to be 17 pi. This will just be minus over 4 minus what? 16 pi over 4. This is just going to be what? Pi over what? Pi over 4. And you can see that pi over 4 is the right answer, since what? Pi over 4 is less than what? It's less than 2 pi. So the correct answer is this one, pi over 4. All right, we can stop. So now let's look at D and E, okay? So for E, we are looking at what? We are looking at 7, just ordinary 7. As you can see now, this 7 does not have what? It does not have, there is no unit attached. So that simply means it is in radian, right? All right. So to answer this question, what you need to do here, it's 7 rad, but the question is you check this 7 rad. Remember, we find the coterminal. If you want to find the coterminal, it's going to be 7 plus minus K2 pi, right? Okay. But the first thing you need to check now, what do we do? Do we use plus or do we use minus? So now it depends. You need to know what is what. What is 7? Is it greater than 2 pi? Because we need an angle between 0 and 2 pi. But for this case, we're going to use something this one. You know, this is like if you have 0 here, this is pi over 2. This is pi. This is 3 pi over 2, right? And this is 2 pi. But what is pi? Pi in this case is approximately 3.14. So which means that this is approximately 1 point, let's say 1.5 something, right? 0.28, right? So this will be approximately 6.28. And 3 pi over 4, which means 3 times what? 3 times 3.14 is about 9 point something. So let's say about 4 point something, maybe. But yeah, let's say about 4 point, let's say 4.2 something. All right. So these are just approximately values, approximate values. So let's work with it and see how this will help. So, but this is 7. So you can see 7 is already greater than what? 6.2. So simply means that this number here, we need to remove from it. So we are going to have that the coterminal, let's do it here. So our coterminal is going to be 7 minus k2 pi. Please watch. Why am I using minus? We're using minus because 7 on its own is bigger than what? 6.28, right? So now you ask yourself, how many rotation? What should be k? So we start with k is equals to 1. If you take k equals to 1, our coterminal will be 7 minus what? 2 pi, right? But what is 7 minus 2 pi? You see that 7 minus 2 pi is just going to be approximately 0 point something, because remember 2 pi is what? 2 pi is 6.82, right? So 7 minus 6.28 is already, let's say, almost 0 0.7 something. So this is approximately 0 0.7. So you see, and this number is less than what? 2 pi. So we're fine. So our final answer, coterminal, is just 7 minus 2 pi. Okay. So let's do the similar one here. And this is 10. So for 10, we're going to do the same thing here. You know, the coterminal is going to be 10 plus minus what? K2 pi. But we know 10 is going to be bigger because we're using the same pi over 2 here. Pi, which is approximately 3.14, and 3 pi over 2, which is approximately 4 point something here. Here is 0, here is 2 pi, which is approximately 6.28. So clearly we know that what? 10 is greater than what? 10 is greater than 2 pi. So it means coterminal is going to be 10 minus what? K2 pi. And this is why, since 10 is bigger than what? Is bigger than 2 pi, right? Okay. Now you need to know, we can start with k is equals to 1 as well. If you start with k is equals to 1, so the coterminal will be 10 minus what? 2 pi. But what is 10 minus 2 pi? Will it be okay? Let's see. I think it's fine. Because 10 minus 2 pi is like 10 minus what? 6 point what? 6.28, right? So that will be around approximately 3 point something. Yeah. Let's say approximately 3.7 something. So this is good. And we know that 3.7 something It's less than what? It's less than 2 pi, because 2 pi is 6.28. So it means that k equals to 1 will do the job. Right, now this is since what? This is approximately equals to 3 point, let's say 7, which is less than what? 2 pi. Or less than, you can say it's less than 6.28. So that is the coterminal. All right. So now example 6, it says if 0 is less than alpha, less than what? 360, and coterminal with minus 870, then what is alpha? So here, what do we do? Is simply find the coterminal, right? How can we get the coterminal? The coterminal here is what? We find the coterminal minus 870, then plus minus k of what? 360. Now, since we want the angles to be positive, so this will be minus 87. We have to use the positive one, then 360. So it means we have to try until we get the what? The positive number, which is between 0 and 360. So for example, if you take k to be 1, if we take k to be 1, what do we have? 870 plus what? Plus 360. This is when k is equals to 1. Definitely this is going to be a negative number, right? This is going to be a negative number. So it means we have to increase the k. So this is k is equals to 2. If k is equals to 2, you have minus 870 plus what? 720. You see, this is still less than 0. This is still going to be less than 0. So it means we still have to try k to be 3. If k is 3, you have minus 1870 plus what? 3 times this is 1080, right? Yeah, and you can see that this will be positive. This will give us what? 210 degree. So we can stop. So this now becomes our alpha. So our alpha should be 2. This is the coterminal. Right. You are going to get other coterminal, but there will be more. For example, if you take k to be 4, you're going to get a coterminal, but that number will be bigger than 360, right? So we take only this one, 210. Now, example 7 says if beta is the least positive coterminal angle. So here you're looking for the least positive. What do you mean by least positive? Least positive simply means the smallest possible, the smallest positive coterminal to this number. So let's write the general. Coterminal is going to be minus 1125 plus minus what? K of what? 360, right? 360. So since we are looking for positive, it means we have to keep increasing. We have to use plus k 360. So if we try k to be 1, this will become minus 1125 plus what? 360. But we know that this number is still less than 0, right? So it will not work. Now, k is equals to 2 will be minus 1125 plus what? Plus 720. This is also going to be less than 0, right? So we try k is equals to 3. K is equals to 3, you have what? 25 plus what? Now, if you look at this number, which one is bigger? Minus 11225 is still bigger, and it's the one that is negative. So it means that this is what? Less than 0, right? So it means we need to go for another k. So we keep increasing the k. So this is 1125. If k is equals to 4, remember I'm using this formula here. So don't forget, this is our formula, k 360. If k is equals to 4, you need to multiply, you multiply 4 by 360. So we are doing 360 multiplied by 4. This is around 1,440, right? And now you see now this will give you a positive number because this is bigger, right? This will give us around 310, 315, right? So this is the first positive number that you will meet. So this becomes the what? The smallest which is the least positive coterminal. So beta is nothing but 315 degree. And for the question is the question asks us for what? Beta plus 10. So beta plus 10, it's simply what? Is simply 315 plus 10, which is going to be 325 degrees. And that is why you see this answer is C. All right. Now, for example, 8 is asking for what? The greatest negative coterminal angle, greatest negative. So how do you answer this one? You start with this, the same thing. Our coterminal is going to be, you see, this is a positive number, right? And we have plus minus k2 pi in this case. Now, since this is positive and you want to have something that is negative, we have to use the negative. So it will be minus k2 pi. Now, you keep subtracting 2 pi until you meet the first negative angle. That will be your greatest negative coterminal. So, for example, we take k to be 1. If we take k to be 1, we'll have 50 pi over 9 minus 2 pi, which we can write as 50 pi over 9 minus what? 18 pi over 9, right? And you see this is going to be greater than 0, right? So we have to try k is equals to 2. If you try k is equals to 2, you will have 50 pi over 9 minus what? Minus 4 pi. Yes, which we can write as 50 pi over 9 minus 4 pi is going to be what? 36 pi over what? 9. This is still going to be positive. So it means we cannot use this. So we go again, increase the k to k is equals to 3. If k is equals to 3, you will have 50 pi over what? 9 minus what? Minus 6 pi, right? And this is nothing but 50 pi over 9 minus, this is going to be 54 pi over 9. And this is going to be minus what? 4 pi over 9. So this is the first one we're going to meet. And this will be at k is equals to 3. We stop because this is less than what? This angle is less than 0, right? So it is the first that we are going to meet when the first coterminal that is negative. So it becomes our greatest negative coterminal. So in that case, we will take our alpha is minus 4 pi over 9. Again, so alpha plus pi is going to be minus 4 pi over 9 plus pi. And yes, and this is what? So we have what? Minus 4 pi over 9 plus pi. This is something minus 4 pi over 9 plus what? 9 pi over 9. And this will give us 5 pi over 9. Okay, so that is the video on coterminals. So thank you for watching. If you have not subscribed, kindly do that and also share this video with your friends.